Here comes our second example. This is going to be a rotation over a horizontal line, but it has holes in it. So here's the shape. We have a graph. The red line in this particular case is the equation, the square root of x. The blue line is the equation 1/10 x. The green line is the equation x equals 4. And I'm going to show you a YouTube video where someone did this already, where they rotated around the x-axis. So here you go. There it gets rotated. Check that out. Do you see that there is a hole in the center? So like when I look at it from the side, there's a hole, and when you cut out the cross section, it's a circle with a hole in it. Pretty interesting, huh? So when we come back over here, what we're seeing is we have a circle with a gap. And how do we find the cross section back in geometry? You would say, okay, well, how do I find this shaded region right here? Well, you would find the area of this outer circle. You would find the area of this gap circle, and then that would give you the area of this shaded region right here. So that's the same thing we're going to do here. We have a circle with a gap. So when we say, well, what's the formula for the circle with the gap? What's the area formula? It's pi big R squared, the outer circle squared, minus pi R squared, where the R is this little gap right here. Now, how do we figure that out? Well, look, let's go back over here. The big radius is going to be from the outside function. You can see I put a little dot right there to show you, to what you're rotating it around. So this center right here. So let's just go back over here. The outside is the outside of this function, which is the square root function right here. And the center is the line that you're rotating around, which is the x-axis. So to find the big radius, we do the red minus the black function. Again, the red, square root of x, minus the black, which is the x-axis. So square root of x minus 0, which gives me that the radius of the big one is the square root of x. And then how do I find the radius of the little circle, the gap circle? And that's there's this cross section when you see it after the rotation. Here's the gap circle right here. Well, it's whatever this line is to the center line. Let's go over here. That gap is created by the blue line and the black line. So we're going to do blue minus black. And what was the blue line's equation? Well, it was 1/10 x, and the black line's equation is 0. So the radius of the inner function is 1/10 x. Okay, so in this particular case, when we go to do the volume, remember, we determined that this was a circle with a gap in it, or a circle with a hole in it. So when we do the area, we have to do pi big R squared minus pi little r squared, or pi outer circle squared minus pi inner circle squared, okay? So here's what our volume looks like. The volume is from the lower bound to the upper bound, pi big R squared minus pi little r squared dx. And remember what I said to you before, I could simplify this. The square root of x squared is just x, so I could have just written pi x here. And over here I could have written pi 1/100 x squared. And because they both have the constant pi, I could have put the pi on the outside of the integral. I'm not going to do that. I'm going to leave it unsimplified in the integral. Lower bound, upper bound, pi r squared outer circle minus pi r squared gap circle is going to give me the volume of that solid that was created. And there's my answer to the problem. So this is different from the previous problem in that the previous problem was a solid with no gap, no hole, and this is a gap